All right, let's look at the homework 2.8, problem number 2. All right, so let's find the derivative of this cubic function using the definition. All right, so let's do that. All right, so we want to find a prime of p. All right, so the definition is limit as h approaches 0. Then we would have to do a of p plus h. We usually use x, but in this case, variable is p, so we have to use that. Minus a of p all over h, right? Then using the function notation, we can write this difference quotient here. So you have a of p plus h. So every time we see p in the formula, we're going to put p plus h instead. So we have 5 p plus h to the third power plus 2 times p plus h. Right? So that's a of p plus h, and then minus. And we just have to subtract the original function, which is 5 p cubed plus 2p, right? Make sure to put a set of parentheses because this negative sign applies to each term. And then you have h on the bottom, right? Then we're going to multiply out so that we can see if we can cancel anything out. All right, so if you multiply this out, let's see, let's do it here. So we know that if you cube this guy, maybe I'll do it over here so that we have more room. If you, p plus h cubed would be p cubed plus 3p squared h plus 3ph squared plus h cubed, right? Then we would have to distribute the 5 to each term. So I'm going to put 5 p cubed plus 15 p squared h plus 15 ph squared and plus 5 h cubed. All right, so that's that. All right, then here you just have to distribute 2 to both of these terms. So you're going to have a plus 2p plus 2h. All right, then we want to distribute this negative sign to both of these terms. So you're going to have a minus 5p cubed minus 2p and all over h. All right, see if we can cancel anything out. So you see that the 5p cubed minus 5p cubed, and we have 2p minus 2p. So we can cancel those out. All right, so leftover terms on top have at least h in common. So I'm going to pull h out. So factor h out, right? So if you look at this guy, so h is pulled out. So what's left is 15p squared, right? And then from this term, if you pull h out, so you're going to have a 15 ph. And then from this term, if you pull h out, so you're going to have a 5h squared. Right, then we have, there's a 2h there, so if you pull h out, you're just going to get 2, right? And that takes care of everyone, so h on the bottom, right? Then we don't need this line here, right? All right, then you can see that we can cancel h on top and h on the bottom, common factor on top and bottom. and then h is going to 0. So since h is going to 0, so this term, 15p times 0 is going to be 0. So this is going to be 0. 50 squared is going to be 0. So those two terms will go away. And then what's left is going to be, there's only two terms left, 15p squared plus 2, right? So we have a 15p squared and plus 2, right? So that's the derivative there, right? So let's type it in. We have 15p squared plus 2, right? Let's check the answer first. All right, I came back and it looks like we got the correct formula for a prime of p, right? Next question is state the domain of the function, right? So the original function is a cubic function, which is a polynomial function of degree 3. Polynomial function is defined everywhere, so its domain is going to be negative infinity to positive infinity, right? And then state the domain of its derivative. Its derivative is actually a quadratic function, so it's another polynomial function, but of degree 2. So, but the domain is negative infinity to positive infinity. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.